Hello and welcome to this lesson about special triangles. As a reminder, this chapter is primarily about properties of two-dimensional shapes and how we can use those properties to do mathematical calculations. And the special triangles that we will talk about in this class will be very relevant to our ability to calculate angles in triangles. We will see these applications in the next lesson. For now, we're merely going to take a careful look at these triangles themselves, at isosceles, equilateral, and right-angled triangles. So let's start with the isosceles triangle. An isosceles triangle is a triangle with two equal sides. We call these equal sides the legs of the triangle. So there is another side, and that we call the base. The angles near the base are called the base angles of the triangle, and the angle near the other vertex is called the vertex angle. Mind the fact that these names depend on what the equal sides are. The vertex angle is not always in the top. For example, in this triangle, the legs are here, so this is the base, so these are the base angles, and this is the vertex angle. You may have noticed that the equal sides imply that the triangle has line symmetry. I can divide it into two equal smaller triangles here, and that has the important implication that the base angles are always equal. They are simply each other's reflection in this line of symmetry, and that is going to be very useful for our calculations later. A special kind of isosceles triangle is the equilateral triangle. Here, not just two sides, but all sides are the same. So we see it meets the condition for being isosceles. For example, these could be the legs and this is the base. But in this case, I have not just one line of symmetry, but I have three. There's also one here and also one here. And each line of symmetry gives me a pair of equal angles. So the conclusion is that in a triangle like this, all angles are the same. And that means that the equilateral triangle also has rotational symmetry. I can turn it 120 degrees around its centroid, and then it will overlap with the original triangle again. The third type of triangle that we will see a lot is the right-angled triangle. The definition is very simple. If the triangle has one right angle, it is a right triangle. Now, your practice exercises will not involve calculations, but they will help you to explore these definitions further and get a feeling of the kinds of symmetry involved in these types of triangles. And then in the next lesson, we'll be ready to start calculating in these triangles. So see you then.